If you feel difficult to write, you can write like this. Say the different robot the configurations I'll be showing you. And if you feel difficult to write, see, our point is not to write a decorative figure. It is not required. Okay, you have to show specifically what I required. You have to show that. See, look here. The first one, the Cartesian coordinate robot, how it can be shown, I'll show. Very simple mechanism. Link, one link. Cartesian coordinate robot. Very simple figure. Is it not possible to show? And you can show the R mark here. This moment is okay. This moment is X direction. And this direction and this direction. Okay, arrow marks X, Y, Z. You can write. Is it possible to write? You can write R X, that is X, Y, Z. Or is simply you can write X, Y, Z itself. X, Y, Z. This is the Cartesian coordinate robot. Okay, and how we can write the cylindrical coordinate robot? The cylindrical coordinate robot can be written like this. See, you can write like this: cylindrical coordinate robot with the rotation at this end. It can rotate here. You understood my point?
Yes, sir.
Yeah, and rotation here. And another one, this is Cartesian, this is cylindrical, and another one, the spherical. How you can write the spherical or polar coordinate system? You can write like this. Look here. Okay, and it can rotate here, and it can rotate here, and it will be having the end effector at the end. end effector at the end. This much is enough. Okay, this much if you write, it will be more than enough.
Okay, sir.
This is called as end effector of the robot. Okay, this is called end effector of the robot, and this I'll write for all these things. That's all. End effector of the robot, and it will be having rotating joint here, and it will be having rotation here also, and the arm can be moved front and back. Just you can see here, the arm can be moved front and back. No, it will be linear and it will be rotational, and this will be rotational. Okay, this is called a spherical coordinate system. And another one, if you talk about the other one, what is that? The articulated robot. If you want to talk about the articulated robot, it will be like this. You need not to write a very complicated figure and show that you can able to do it. It is not required. See here. That's all.
Yes, sir.
Okay, now. Very simple. Try to reduce the figure. Try to reduce the figure and write it. See, this is the rotation here, and rotation here. Okay, rotation here also. You understand my point? Okay. Okay, here also it is having rotation, and here also I'll show here the rotation how it will be. That's all. You need not to waste too much of time to write it. So if you happen to get this for the test also, please write this one only. You can see that you can find theta 1, theta 2, theta 3 here. Correct? No? This is the Cartesian coordinate, robot, linear. So this will be 3L, and it will be linear. You are understanding me? And it will be linear movements.
Yes, sir.
Yeah, it will be linear movement, and this will be rotation here. This arm can be rotated like this. This arm is there, no? For example, this arm can be rotated like this. About this point, it can be rotated like this. You understood my point? It can be rotated. You understood? So this arm can be rotated. This arm can be rotated like this, so that it is a rotation along this axis, and this is the retraction, and this is moving up and down, so that this is called 1L and 2R robot. Correct? Okay.
Yes,
and the
sir.
next one, and here it can able to rotate here. Okay, it can able to rotate here, and it can able to rotate here. It can able to move like this, so that it will be having 1L and 2R. And the last one, it is giant arm articulated robot, or simply a SCARA robot. You can say this is having rotation here, and rotation here, so that this is called 0L and 3R robot. And you can see that once the rotations are increasing, the mechanical stability goes on decreases, and it will be very worster in this case. Mechanical stability, repeatability and accuracy will be very less once because of three the rotation joints are there. As compared to this, this will be having little more better. As compared to this will be having little more better. And this is, you can see that your house will be constructed the circular or spherical or rectangular.
A rectangle, sir.
Yeah, because the rectangular is having very good stability, mechanical stability. So that, correct, no? Since
Yes,
the
sir.
rotation once goes on, increases the rotations, rotating joints, what happens? The mechanical stability will be decreased and the repeatability and accuracy will be decreased. So that we should have to have the better controllers we required. Okay, and these robots, okay. And okay, let us discuss these differences between them. Okay, so the coordinates are Cartesian. This is a Cartesian coordinate robot. The work volume generated will be Cartesian. The work volume generated will be cylindrical. The work volume generated will be a spherical. The work volume generated will be complicated. We cannot able to show for this. And the mechanical stability will be very good in this, and it can able to perform pick and place. And mechanical stability will be lesser as good compared to this one, because one rotation joint is increased in this. So to compensate that, we'll be using a better controller, and this can able to perform pick and place. This also can able to do pick and place along with a simple welding and the spring operations. And let us come to this. It will be a spherical or segment of a sphere, and the mechanical stability will be not good than these two. So that it required a little more better controller, because two rotational joints are increased this. And the what kind of application will you be using? You will be this can do all these operations what this can do. So pick and place you can do, and it can do simple welding and spraying operations. Along with that, it can able to perform the assembly operations and complicated welding and the painting operations it can able to do. So almost all the industrial robot will be having these three types. Okay, these three types. Now let me come to, you understood the joint arm articulated, this one, and this is vertical joint arm articulated. And if you talk about the horizontal will be like this. Horizontal will be like this. This is a frame structure. Okay, this is a frame structure, and here the robot, this one will be there. That's all. You need not to write a very complicated figure and show that. It's not required. Okay, and here the end effector will be there. At the end of this, there will be end effector. Is it possible, Varun, you can able to write? Yeah, end. It is horizontal scara. And it is vertical scara. Vertical scara. Okay, and now, as now, if you want to discuss something about its features, these robots are having the coordinates r theta theta, r theta 1, theta 2, theta 3, theta 1 at the base, theta 2 in between, and theta 3 there. You can see that this is one rotation, and this is the other rotation, this is other rotation. These are all three will be rotational joints, so that it will be very, very complicated to govern the rotation of these robots. So required sophisticated robot controllers. The mechanical stability of these robots will be very versatile because all three will be rotational. Okay, and stability and repeatability will be not good enough, so that we'll be using the better controllers to compensate that. One thing, the work volume generated by these robots will be not having proper shape. These are not having proper shape, and this is very, very important. The work volume you have to show. Okay, work volume, if you show this much, it is more than enough. The work volume of these robots. The work volume generated by these robots I'm talking about. Work volume. Correct? No, it is called work volume of the robot. Volume of the robot, you can say. And you can able to, I told you, you can able to divide it into equal parts. It's not a big problem in this. Correct? No, so that these robots are having very good stability, the repeatability and accuracy, and even the mechanical stability of these robots will be very good. Correct? No? Are you understanding me?
Yes, sir.
Yeah, good. Just I am showing here only. It is self-explanatory. Self-explanatory. See that all these will be having uniform in shape. And next, let me come to the work volume of this. All these I'll be showing here only, so you can able to remember it. Correct? No, the work volume generated by these robots will be like this. It is called cylindrical coordinate. And if you talk about see, the work volume generated will be like this. Correct? No, it will be smaller here, it will be bigger one. That means the repeatability and accuracy will be very good when the arm is not extended. once the arm is extended more, the repeatability and accuracy will be poor enough here in this case. Correct, no? And these are called the cylindrical coordinate system. And the spherical coordinate system, the spherical, it will be in the form of a sphere, as I told you. It will be in the form of a sphere, okay? And a segment of a sphere it will be. It will be just like this. It will be a sphere, spherical shape. In the form of a sphere it will be. You can see that it will be in the form of a sphere. It is like this, okay? And even if you want, you can write here also. Yeah, it will be like this. It will be like this. Yeah, I hope you can able to understand this. Now, I was talking about at least along the vertical axis, these segments will be there. These below this, the same segment will be there. Below this, the same segment will be there, and it will be having at least up in the vertical axis, having a good accuracy and repeatability. But in case of these, the spherical robot, it will be very versatile. Correct? No, this is what I wanted to say. Now, where all you can use these giant articulated robot arms. These robots will be used for all kind of applications wherein it will go for the machine assembly, machine vision applications, inspection, testing, any kind of very delicate works it can able to do.